So we are into the last lesson in module 11 under geometric figures. And we are going to be talking about three-dimensional figures now. And our learning target, I can describe three-dimensional figures and determine the shapes resulting from horizontal, vertical, and angled cross sections. The vocabulary we'll be talking about are bases, cone, cross section, cylinder, edge, face, plane, polyhedron, prism, pyramid, and vertices. Okay, so let's talk about, before we get into polyhedrons, let's quickly talk about polygons. So polygons are basically your two-dimensional shapes. And, for example, we've done that. It's got, the smallest is like 3 sides, and that would be triangle. Four sides would be quadrilateral. 5 sides pentagon, 6 sides hexagon, 7 sides would be heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon, and then it carries on. But that's basically what polygons are. And now we're going to get into the three-dimensional. So instead of gon, like, when you say polygon, we replace it with polyhedra. Okay, so that's why we are saying polyhedrons. And when we have more than one, it is obviously, we're going to talk about polyhedra. So what is a polyhedron? It's a three-dimensional figure or solid with flat surfaces that are polygons. Here is an example. Here's another example. So these are all polyhedrons, okay? And here, all different types of polyhedra. And here, okay? So we'll quickly talk about what these are. So these are all different types of polyhedra. And here. Okay, so let's quickly discuss. See, prisms and pyramids are types of polyhedra. Okay, so prisms and pyramids. So look, here is a prism on my right. Here's another example of a prism. Look at the top and the bottom. And prism, top and the bottom. Okay, and then we have pyramids, which are determined by the shape of the base. Okay, so these are pyramids. Okay, so so these are types of polyhedra, and polyhedra is the plural of polyhedron, and that's what I was trying to tell you. Okay, so a prism is a three-dimensional figure with at least two congruent parallel faces called bases that are polygons. Okay, so bases that are polygons. So that's a polygon, that's a triangle, and that's a triangle, the top and bottom. So that's two bases. Okay, this one, again, a prism, but what is the base? It's a hexagon because we have 6 sides. So this is a hexagonal prism. And the one I showed you before was a triangular prism. Square prism, also called a cube. Rectangular prism. All right, so based on the base, you have two bases that are exactly the same. And so prisms are basically named by the shape of their base. Okay, so let's talk about a pyramid. And as I had shown you earlier, a pyramid is a three-dimensional figure. It has one base that is also a polygon, not two bases like in a prism. Okay, so one base, and then look at what's happening at the top. Okay, so It has one base that is a polygon and other faces that are triangles. So one base, this one here is the triangular base, and then the rest you have your triangular faces. Okay, pyramids are also named by the shape of their base. So this is a square pyramid, triangular pyramid, based on the, again, named on the shape of the base. Okay, now so I am going to go ahead and draw a prism really quick. Okay, so let's say I draw a rectangular prism. And yes, this might not be the best, but this is pretty easy how to do it like this, right? So we have, all right. So here is a prism. It's a three-dimensional shape, okay? And so if I try to describe what these words are over here, and let me go ahead and do, this is A, B, C, D. Okay, the D is not very clear. Let me just do this again. Okay. This is D. All right. And then E, F, G, and H. Okay. So I've just like gone ahead and, labeled the different vertices. But let's say if I took this, the diagram shows the parts of a prism, the faces, the edges, all right, and the vertices. So these are the three things that we are going to talk about when I show you this. So let's say I just do this part and I just color this whole thing. Okay, so this is nothing but this part, see, the side. Okay, so when I'm saying that, that is, what is this part? This is called the face of a prism. So a face is a flat surface of a polyhedron. Flat surface of a polyhedron. Okay, and so if I look at this rectangle, C, D, H, G, this is one face. So literally, like, it's like looking at a box. Okay, here's one face. So you have front and you have a back. You have two sides, side and side. You have top and bottom. So as you can see, there are 6 faces in this. It's also called a hexahedron. Depending on the number of sides, that's basically what it is called. Okay, so now let's look at the edge. And the edge is the line segment where 2 faces of a polyhedron meet. So let's look at line segment BC. Look, line segment BC. Remember, line segment is written like that. So this is one edge. Here is another edge, and another edge, and another edge. And these are edges. Okay, these are edges. So when you are looking at all that, we have different edges over here. Okay, and what is a vertex? Vertex, such as E, for example, this is where 3 or more faces of a polyhedron intersect. And vertices is the plural of vertex. So these are all my vertices that I have, the A, B, C, D, E that I have over here. Okay, now we also have other solids that are not polyhedra. So the examples of not polyhedra are a cylinder. See, it has a circular base and a top. Okay, but it doesn't have the sides. So it is going to be circular. Same thing with a cone. It has the base and then it is just congregating up like this. Okay, so these are also polyhedra. Okay, sorry, they are not polyhedra. All right, now so a cylinder is a three-dimensional figure with two parallel and congruent circular bases connected by a curved surface. And a cone, it has one circular base connected by a curved side to a single point called the apex. So this is called the apex over here. Okay, so once again, because these have curved sides, they are not polyhedra, but they are 3D shapes. So why are cylinders and cones not polyhedra? Because polyhedra are figures with flat surfaces and faces that are polygons. So flat surfaces that are polygons. So they have surfaces and faces that are flat, that are polygons. But in a cylinder or in a cone, there's no flat surface. Okay, they are circular. Both cylinders and cones have curved surfaces and circular faces that are not polygons. Therefore, they are not polyhedra. Okay, so now I'm going to show you some examples, and then we are going to identify what the figure is asking. So let's look at this one. Okay, and it's saying the figure shown is a rectangular prism. Find the number of faces, edges, and vertices. Okay, so let's look at this. Which ones are the faces? So the faces are the flat surfaces of the prism. As I said, the prism has a top and a bottom. Okay, it has two sides and it has a front and a back. Okay, so how many faces does that make? That makes it have 6 faces. And because it has 6 faces, it is also called a hexahedron because of the 6. Remember when we talked about polygons, 6 sides is hexagon. So because this has 6 faces, it is a hexahedron. Okay. Now, we're going to find the number of faces, edges, and vertices. So we just said it has 6 faces. All right. Let's look at all the edges here. Okay. So let's talk about how many faces. Okay. So we had faces were 6. Let's look at how many edges are there. Edges are all of these. This one and this one. So every line segment that is connected. All right. So we have A, B. We also have these. These are all line segments, right? So we have AB. All right. We have BC. We have CD, and we have AD. Then we have CG. Okay. So these are all line segments. So CG, we have GH, right? We have DH. These are all line segments. We have FG. Okay, this one. Then we have EH, this one. Then we have EF. And we have AE. And we have BF. So look at all the edges because these are all the different line segments that we have. So when I look at that, we have 12 edges. All right. And let's talk about the vertices. How many vertices do we have? So that is 1, 2, 3, 4, 5, 6, 7, and 8. So each of those are vertices. So we have 8 vertices when we look at this shape. All right. Now, let's look at another one. Let's look at this one. So this is a triangular prism. Okay. So this one is a triangular prism. I'm trying to find, okay, here we go. This is a triangular prism. So look at that. All right. So in a triangular prism, how many faces do we have? We have this base and this base, so top and bottom two, and then 1, 2, and 3. So best thing to remember about a prism, you look at the base. All right. So this is a triangle. That would be 3 sides, right? If it was a polygon. So I would just say 3 faces, this. And because it's a prism, the top and bottom, so plus 2. So that is 5. In this one, I look at the base. 1, 2, 3, 4 faces, right? 4 faces. And then because it's a prism, I'm going to have a top and bottom, so plus 2. So that gives me 6. Okay, let's look at this one. I'm just trying to show you how to remember how many faces they're going to be. So this one, 1, 2, 3, 4, 5, 6. So I have 6 faces and top and bottom. That would be total of 8 faces. Okay, so just remember based on the base how many sides lengths they are, and then plus 2. That tells you how many faces that prism is going to have. So I just showed you a triangular prism. And the base is what? A triangle. That's 3 sides plus the top and bottom. That's plus 2. So 3 plus 2, that gives me 5 faces on this. So that's a really easy way for you to calculate how many faces there are going to be, in a prism. And then I'll show you the trick of a pyramid in a little bit also. Okay. So now let's look at how many edges are there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we just said that we have 5 faces, we have 9 edges. All right, and then let's look at how many vertices we have. 1, 2, 3, 4, 5, 6. So we have 6 vertices. All right, so that is how we are checking as to how many faces, how many edges, how many vertices, etc. All right, now let's quickly talk about a cross section of 3-dimensional figures. Okay, so a plane is a flat surface that extends forever in all directions. And the intersection of a solid and a plane is called a cross section of the solid. So let me just show you some examples. So here is an example of the different types of cross sections. And this is showing one of a cylinder. Okay. So once again, a plane is a flat surface that extends forever in all directions. And the intersection of a solid, okay, and a plane is called the cross section of the solid. Okay. So like this is the vertical and this is the angled. So as you can see, a horizontal cross section results in a circle in this case, because look, if I cut it, what's happening? You're getting a circular object. Do you see that? Okay, and this is for a cylinder. Okay, let's look at the vertical cross section in this one. So when I do it vertically, I'm left with a rectangle, as you can see in the middle. And then let's look at the angled cross section. So if it's angled as in the cross section, I am going to end up with an oval in this case. All right, so that's how we look at the different types of cross sections. Now, let's quickly do a cross section of, let's say, a pyramid. Okay, so let's look at this one. A square pyramid is shown. Describe the shape resulting from a horizontal cross section, a vertical cross section, and an angled cross section. So let me find a pyramid for you. Okay, so if I take this pyramid and I find the cross section horizontally. That means I just cut it across like this. So what am I going to get as the shape? So look over here. All right. So because of this, when I cut it horizontally and I do the cross section horizontally, I am going to get a square. All right. Now, let's see what happens when we cut straight down. We find the cross section vertically. So if I was to take this triangle, there's a triangle here, and I, do the cross section like this, I am going to end up with a triangle. So it would be triangle if I did the cross section vertically. Okay. Now, if I took this and I did the cross section in an angled form, Okay, so it goes down like this, and I'm going to show you some pictures right now. I would actually get a trapezoid. Okay, so let's go ahead and show you some examples of that. And I just wanted to have a visual of what I'm talking about. So let's see if I can pull this up. And there we go. So this is exactly what I was talking to you about. See what happens to this? So when you are, doing the horizontal cross section, you're going to get a square. Okay, vertical triangle. If you do it angled, you are going to end up with a trapezoid. Look, trapezoid. All right. Now, why is the cross section through the center of a sphere always going to be a circle? All right, no matter which way it is sliced. So we know that what is a sphere? A sphere is going to be completely circular. It's like a ball, right? So the sphere has the same shape and size from any angle. So its cross section is always going to be a circle. All right, let's look at this one and describe the shape resulting from the vertical cross section of the triangular pyramid. So again, vertical, what do I get there? I get a triangular shape if I find the vertical cross section of a triangular pyramid. All right. Now, so let's describe cross sections. Describe the shape resulting from a vertical cross section, a horizontal cross section, and an angled cross section of this. Okay, so this is nothing but it's saying a rectangular prism is shown. Okay, and what's going to happen over here? Horizontal cross section is definitely, if I go this way, what am I going to get? I'm going to get a rectangle. Okay, can it be a square? When I do the cross section in this case, no, because in a square, all the sides have to have exactly the same measure. So if I am splitting it like this, look, this is less than this. So therefore, that's why we get a rectangle, not a square, if you just look at that. Okay, if I do the vertical cross section, I still get a rectangle. And if I do an angled cross section, I will also end up in a rectangle. So let me just show you what I mean when I say that. And I just wanted to have a visual of what I'm talking about. So look, this is the horizontal cross section. Okay, it results in a rectangle, and this way also. Look, what do I have here? It is a rectangle. Okay, now describe the shape resulting from the cross section of the triangular prism. So what do you see here? It is going to be a triangle. All right, and so one thing, Mario states that all of the faces of a cube are squares. And for this reason, the shape resulting from the cross section of a cube is always a square. Okay, that is according to Mario. So let's look at this one. And no matter which way the cube is sliced, according to Mario, you are going to get a square. So is Mario correct or incorrect? All right. So if I look at this, it is a cube. And I was just talking about that in a little bit. Okay. So if I cut the cube vertically, all right, so look, this and this are going to be different measures. And in a cube, I have got to have all the faces that have exactly the same measure, right? So because of it being like this, here, down, okay, this part is going to be less than this part. That makes it a rectangle. All right, same thing if I do it horizontally. Look, I will still get a rectangle. If I do it angled, I will still get a rectangle. All right, so in all the cases, I am getting a rectangle and not a square like Mario is thinking. All right, so just basically in this, please remember what exactly is a polyhedron, and how do we find the cross section of each of these. All right, and so again, cross section can be the three different formats and three different types of cross section and that we have, and that is your vertical, it can be horizontal, it can be angled. And so we are being able to describe the shapes resulting from these different cross sections in this lesson. All right. So have a great day. And that concludes our geometric figures, which is module 11. Have a wonderful day, everyone.